So, very welcome to all of you, and I'm happy to be here and share this breakfast seminar together with Nivi. We only have 1 hour, and we have 4.5 talks, so without further ado, I'd like to invite Enrico Davoli to the floor. So maybe you can use this. And I'll start the presentation. So Enrico Davoli is from Milan, Istituto Negri.
Okay. So thank you. Thank you very much for the invitation. Thank you very much for the invitation. It's always easier and back to work than the microphone. Always, as we know. So.
Now we formally start.
Thanks, Enrico. So thanks. First, thanks Mastec for inviting me. Thanks Peter for organizing this very packed morning session. And thanks to you all for coming. I just arrived from Italy and I'm terribly jet-lagged, but you are not, so I'm very close to you that you're here Monday morning at 7 a.m. You hear me? 7 a.m. in the morning. So I decided not to put data, but just pictures, so to make it easy for a 7 a.m. Monday morning presentation. So I will give you some, I had the pleasure to receive one of these portable mass spec to play with, and I will share with you some analysis we've done on those. So I come from a large research institute, and inside the institute I have made this mass spec research center mainly to manage the high cost of the instrumentation. I want to share this with you because I know, I understand you're all suffering from the cost of the instruments. So last year we received this from Mastec. These are two students that helped me out to open and unpack the instrument, and this is the MT30. There are pictures outside and there's a brochure, and this is how it looks, how it actually looks like. So really tiny and lightweight. And inside there is a real mass spec. Even if it looks like a Barbie-like toy, it is a real, truly mass spec. It has 2 turbo pumps, one just underneath the ion trap and one in the sampling cone. There's a sampling cone and a capillary, heated capillary that will bring the sample inside. There's a quadrupole that will guide the ions, and here's an ion trap. And has amazing specifications for being such a small instrument. Is API, is an ASMS operation capabilities. It will go up to 2,000 mass, and it weighs 37 pounds, and is very small, and it uses little power. So if you have a strong battery, you can operate it on site. So this is the official picture of the very first instrument they developed with this source. And this is what we had modified. I used the instrument last year, to do some work. I presented some work on sex wellness products. I was doing on-site analysis of these over-the-counter products everybody seems to buy. And so then I came back to Mastec and I told them I think that a SPME device would help a lot. And so they built up this SPME holder for me, and I present you some data now. So some examples of what I've been doing this year. Last year, FDA required a PMTA, that is a pre-market tobacco product application for tobacco products to be put on the market. And so the industry started to go around this problem, and they came out finally with the idea to put an electronic cigarette without nicotine, without tobacco compounds inside, and they put 6-methyl nicotine. They call it methatin, it's not nicotine, so it goes around the PMTA. And you can imagine a product that is vaped without any control, how we are happy about this for our kids. So in October, on the market appeared this product, Spree-Bar, and we got to buy one. And first I bought the original standard of 6-methyl nicotine, methatin, and this is SPME, this is the headspace, and you can see that this is the peak of the molecular, protonated molecular ion. And so I was sure I could see methatin by SPME APCI. And then I analyzed the liquid and I found 2 peaks. One was due to the methatin, and one is a dehydrogenated product of the compound. It's an oxidation product. It looks like nicotine. Nicotine is a very well-known oxidation product, nicotine. And so I named it here methatin. And then we ran GCMS with an Orbitrap to validate the compounds, and it was an actual compound. I mentioned to you that it's a real mass spec, so you can play and do MSMS. If you have complex samples, you can run MSMS. So I've been playing with some cannabidiol, CBD. So these are the MSMS parameters I used, 315. Parent ion, 2 masses isolation, and some energy to fragment it. And so this is the standard. This is 100 ppb in water. This is the immersion of the fiber in water. And you can see that there is some molecular ion that is still on the MSMS spectra. This is the base peak, and this is another peak. Something you can find in the libraries. And if this is the reconstructed ion chromatogram of the transition from 315 to 259. You can see there is a desorption that occurs in the very first seconds. These are seconds, and then it goes away. Okay, so we can measure it. I told you that was 100 ppb, just to give you an idea. This is a urine sample. After 1 dose, and after 24 hours, you have about 100 ppbs. And this is a review that recently appeared, 2022, and all the MSMS instruments, more or less, after extraction and chromatography, they can see few ppbs, 2, 5 ppbs. And this is an actual. We came in the morning, we turn on the instrument. This is a time lapse. So the instrument now is pumping down. This is a urine sample spiked with 200 nanograms. So now the instrument is pumping down, 3 minutes. the vacuum is okay. 4 minutes, we started to acquire spectra. At 5 minutes, we take the SPME and we desorb it. You can see ions. And in 7 minutes, we elaborate the chromatography, the desorption. And so this will show you that we can start from a urine sample with the instrument turned off. So we can turn on the instrument, run the urine sample, and detect 200 ppb of CBD in urine. This is the output. 200 ppb in urine is less sensitive than in water. Maybe I should have played with pH or temperature, I don't know. You can still see the 259, but the other fragment is below the noise. But so this is the desorption and the identification. I'll show you another application. This is histamine in fish products. It's a serious problem of intolerance because it already comes from histidine degradation, from histamine that gives intolerance to humans. And this is 5 ppb of histamine in water, desorption. You can see that we dissolve in 15 seconds. And you can see this is the limit of sensitivity is 112, 111, the ion we should see, and we can barely see it. Speaking of fish, I went to the aquarium and I brought the instrument with us. The aquarium of Genova is a very large aquarium. These are tanks where they grow up corals. So we've been analyzing a space of corals. These are baby corals. They're growing up, you see. These are hard corals and these are soft corals. And so we've been analyzing the samples in the aquarium on site. So it was a very harsh environment, water everywhere. And so this is SPME. You can see here some spectra. And we find out with SPME the DMSO in the space of the corals. And I don't know if you were last night here to listen to Kimberly's plenary lecture. She mentioned about the pollution due to ocean, and DMSO, DMS, dimethyl sulfide, and DMSO. DMS is a main pollutant emitted from corals, and DMS will oxidize to DMSO in air, so it's a very well-known compound. If you want to do some quantitative analysis, we are all mass spectroscopists. We do know how to do it, so we just measure with the sample some deuterated internal standard, and you can make a quantitative or a semi-quantitative analysis. So this is more or less all I wanted to tell you. If you have any questions or more curiosity on the application, you just come and see me at the poster Wednesday. And this is it. So these are all the collaborators help me out, and this is the people that really do the job while I'm here talking to you and having fun. Thank you.